Hi guys, welcome again to my YouTube channel. Guys, let's solve this question. I read the question first. Find the principal value of the complex number. So guys, we have a complex number here. As you can see, it's open the bracket square root of 3 minus j1, close the bracket, then you raise that to negative 12. So guys, we can start off that question. So the question is right here. Guys, the first thing we are going to do is to draw what we call an anchored diagram. I believe we have done complex numbers, you have come across the anchored diagram, and this is now the anchored diagram we are drawing. So guys, we are going to do this. We are going to plot this on XY axis, whereby guys, for the real part, we plot that on the x-axis, and because it's positive, guys, it shall be up to there. Shall have from 0 to square root of 3. This distance is square root of 3. And then on this other side, our j is negative. That is negative 1j. So guys, that we plot on the y-axis, representing the imaginary. So we bring a point here 1, and then we can now, guys, that is square root of 3, and here 1 we come, and wherever they meet, we now draw our line. And so this is the line that represents our complex numbers. The first thing, guys, after that we do is to get the modulus. Getting the modulus, guys, it is just now drawing that square root of 3, and here we have 1. Guys, we now find the magnitude of that line, of which, guys, we are going to use the Pythagoras theorem to get that. And that's what we have done here. 1 squared plus square root of 3 squared will give us the square of modulus. So that one, guys, is going to give us 4, because square root of 3 squared is 3, and the square of 1 gives us 1, and so that becomes 4. And so therefore we shall have 4 equals to m squared, and so therefore modulus will be equal to m. Guys, the modulus is always positive, and so we put it as 2. That is our modulus. From there, guys, we come and get the argument. For the argument, this one comes from this point. That is on the first quadrant, and it goes loud up to where our line is. That gives us the modulus theta. For us to get that theta, we can find the angle here, which we are calling phi. And that angle can be found by saying tan phi is equals to opposite of hypotenuse, which is 1 over square root of 3 right here. So tan phi equals to 1 over square root of 3. And that one now gives us 1 over square root of 3 gives us 0.5773. So we now get the inverse of that. Getting the inverse of that of tan inverse of 0.5773 will get our angle as 30. So guys, this is phi. We have already found the phi, but guys, we are interested in getting the modulus theta here. And because if you go around here up to the point where we started, that is 360 degrees. So we take away this phi from 360 degrees. And so we shall have here 360 minus 30, which gives us 330. Guys, now we have the modulus, and we also have the argument. And so we write it in terms of, in polar form. We shall write it as 2. That is, this is similar to square root of 3 minus j. this is in form of polar form. And so guys, now here we come and put negative 12, but now we are putting at the polar form equation. So guys, from there we use what we call the Moivre's theorem, and this is the De Moivre's theorem, guys. It states something like this. That is, if you have R, which is the modulus, and then theta, which is the argument, raise it up to n, this gives us R raised to n, and then n theta. That is the De Moivre's theorem, guys. And so that's what we are going to subject our values here. And then therefore, guys, we shall have 2 raised to negative 12, and then negative 12 multiplied by 330. So guys, now we come and we write 2 raised to negative 12, then we can multiply negative 12 multiplied by 330. When we do that, guys, we can now put them in trigonometry form. Guys, we have already multiplied. So we got here 2 raised to negative 12, and then this one became 3960 degrees. So guys, now we write this in trigonometry form. So when we write that, the complex number in trigonometry form is negative, we shall have 2 raised to negative 12, open the bracket, cos negative 3960 plus j sine negative 3960. Going out to our tables, guys, we shall have cos negative 3960 as 1 and sine negative 3960 degrees as 0. And so therefore we can remove that. So guys, we are left with this value 2 raised to negative 12, which is equals to the same as 1 all over 2 raised to 12. 2 raised to 12, guys, we shall get 1 all over, that is 4096, and so therefore the solution will be 1 all over 4096. So guys, this is our principal value. So guys, thank you so much. It's also called the first value that you get. Bye.